Hello, everybody. We have come together for another hangout today. We are having a concave talk again. We're having like round two, ding, with Joshua. And also who's joined us today is Wide Awake to give some input and to talk about things, because obviously everybody believes something different. But anyway, Joshua and Wide Awake, hello there.
Hi.
Hello.
Hey. Anyway, Joshua, do you want to go for a few minutes then and explain why you're a concaver?
Sure. Let's see, back in 2015 is when it all started for me, with some flat earth material. And so I ended up getting a camera, a P900 and looking at stuff for myself and just kind of absorbing all of everything flat earth had to offer. Excuse me. I got involved with activism, back in New England where I'm from. And I started, getting more confident and, speaking with people, anybody. And so after enough time went by, there's enough unanswered questions where you kind of have to look elsewhere if you're going to find answers, because it just seems like the two camps fighting it out. Neither one of them can really provide enough answers where you really know where your home is. So I started looking for more, and that's when I realized that I had been fooled again. I was wrong twice. So here we are.
Hey, thank you for that. Wide Awake, do you want to say anything?
Yeah, I started into this at about probably 2015 too. But it was kind of funny with me because I started out with flat earth and thought, oh man, these people got to be joking, and then I looked at other conspiracies too, especially like 9/11, which I do kind of agree that it was an inside job to create more war, just like everything always happens to be about war, and but then I started doing some of my own observation. I was an avid fisherman, so I started, doing a lot of observations with my own eyes, especially being that I do a lot of night fishing. I'd leave in the afternoon, or late in the evening, and then come back at after dark, of course. But when I got my P900, I started doing some really heavy observations, and when I did, I started learning more about different optical effects that occur over the atmospheric conditions that we have. And people might say, well, you shouldn't use that word atmospheric, but everybody understands that a lot easier than atmosplanic or whatever you want to call it. So, when I started looking at these mirages nearing the Phantom Morgana, I started seeing a lot of different effects. And then now that I've been really going back through and reviewing a lot of my footage and doing, my own personal comparisons to what I'm seeing, I see how these optical effects can prove a globe, okay, where it does kind of, you get this impression that there's a curvature out there because things do get cut off. And then I can understand where people would say, hey, some days I can see these objects way farther and the water way farther, and everything just it looks like it goes up over your eye level, okay, because everybody's always talking about water rises to the eye level, but here's the problem. Most people will be what's the right word? I don't want to say fooled, but in other words, fooled, because where you're thinking your eye level is, it's not, due to perspective. And when I started looking at some of my observations for where eye level was, and then comparing it to some of my pictures that I took on a really, really clear day, eye level was where I was actually saying that it was at. and that's where I stand. It's pretty level out there.
Okay, thank you for that, Wide Awake. Joshua, what about, because you obviously you've got a P900 as well, haven't you?
Yeah. Well, I wanted. Well, go ahead. What did you want to?
Well, just that you showed us last time pictures that you'd taken.
Sure. Yeah. Oh, I should have brought my thumb drive. That's all right. Yeah. Well, I wanted to say a couple things about level one. The horizon rising to your eye level is not. It doesn't make sense on a convex globe, and it also does not make sense on a flat Earth. The only horizon that rises with the observer is a horizon that's actually rising. So that's number one. Number two, everything remaining level works in every model. So, you know, the whole mantra, you know, water always finds its level. That's true if the Earth is convex, flat, or concave, because anything perpendicular to the center of a sphere, convex or concave, where it doesn't matter, anything perpendicular to that sphere is going to be quote unquote level. So something remaining level doesn't prove any model. It's just a silly thing to say. It's like saying cars drive. I mean, it's pointless. We all know that cars drive. No one needs to debunk that. So something finding its level is just not proof of anything at all. And so it's, you know, there's lots of things about flat Earth that people just take for granted at face value, and they don't really think about it. Like the global flight routes that are misrepresented by the flat Earth community, because they use flat global projections to just flight route, when if you actually look at the actual path of that aircraft around a sphere, you'll notice it's not even taking the same path that flat Earth proponents would purport, and that's concave or convex. I assert the Earth is concave, and that the plane's nose upwards, mainly because the Earth must be convex or concave because of the maps, and the Earth cannot be convex because we can see way, way, way too far. So, I mean, those two factors right there should just at least kickstart your journey beyond flat Earth. Once you realize none of the flat Earth maps are actual working maps, they're just different ways to see or calculate or do whatever. But the only maps that work are the spherical ones, and we don't live on the outside. So at some level, it's that simple, where you have to research the model. And if you want to say, well, concave can't work because of this about the sun or something you don't understand, don't discredit the model just because you don't understand something about it. It's easy for pride to do that to people. Well, I don't understand that, so it must not make sense. Well, in all actuality, it's probably that person's thought process that doesn't make any sense. And so,
can I say something, Joshua? Joshua, you've made me think about things. You've made me think about what's under the water, and I think now that obviously the sky is convex and there's other things going on, and I do understand that while we also say sit in a camp and say, well, I'm this and I'm that, we're never all coming together, and I think there's much more going on than there's just one thing. There's loads of things going on, and you know, there's loads of things going on to make the one, and everybody's looking at a bit of it. But I was on a hangout with Wide Awake, and he was explaining about the corridor effect. I just wondered if he would explain that. What his version of what he's seeing in his camera. Is that all right, Wide Awake?
Yeah, because you know, you're saying that you know, we're not thinking, and that's like, wow, okay.
I wasn't saying anybody in particular. It's a problem that every human faces. That's my point.
Yeah.
Well, I think he means we get so shut off, we have to remain open.
Yeah, because what I was explaining before was that biblical model of what appears to be more like a Russian roulette table with you know, the four winds on each corner. That has cavity to it, okay? But it's not a like living inside the bubble and not outside the bubble.
That model showed convexity in the North America, and I know that the water is not convex in North America. I know that water is concave in New Hampshire, it's concave in Georgia, and it's concave in Michigan. Everywhere else, I can't speak about.
Let me see if I can't. I don't know if I can share. If I can do this, share my screen. How about now?
We can now, yeah.
Okay.
Yeah.
All right. This is my cell phone footage that I do doing low perspective videos. I pull out my cell phone camera and kind of show a little bit of it. And you know, basically, I'm out here filming this little island that's 4.84 miles away, and you can see this little bit of land right here. Now that's not very high off the water. It's only a few feet, and that depends too on high tide. And then I think on this day I got a little better visibility as far as quality goes. And you see this, you know, you see this long, skinny boat going across the screen. You can see pretty much the whole boat in the water, right? And let me see if I get.
So what are we looking at here? What are we getting at? What are we getting to?
Well, you always see these this visible water line, right? And this is where, you know, everybody thinks water level is. You know, they're looking out there saying that's, you know, there's water level. So I'm looking at eye level. You know, if I take my height and I add it out there, that this is where my eye level is.
Watch out for the hook and the worm.
And I want to see if I got it. Let's see if this is the one. I think this is the one. Well, you can see this rack too. It's a little more distorted this particular time of the day. And then let me click on a little bit later in the day, because there's one of these bird racks out here that it's a known distance. I know all these racks. I've been filming these things for like 4 years now. Let's see if it was after this. I think it's after this.
So you're showing that we shouldn't be able to see this stuff because it's way too far, right?
Well,
On the convex Earth?
No, I'm talking about where eye level is, okay? And I wanted to use this one bird rack to kind of show what I'm talking about, if I can find it in here. Maybe it's in this one. Yeah, I think this might be it.
Well, you're going to have a difficult time proving that if you're going to keep your camera up high on a tripod like that. You got to get your camera down lower, in my opinion. Because if you keep your camera on the tripod, you have no way of proving if your camera's level or not, even if you're going to use the auto leveler in the P900. So finding what's eye level is almost a moot point if you can't prove if your camera's level or not.
This is what I'm saying. This is what I'm trying to show, that some of this stuff where you're looking at and, you know, you're saying, well, this is eye level, this is eye level, or whatever have you. That's not the one I wanted to look at. I know it was one of these here. You know, the time lapse.
If you, I can see from your footage that you have done that. You've put your camera down low near the water, and when you do that, you'll notice that that waterline horizon you're talking about is always above center frame. Because you just showed it 2 seconds ago. You had a perfect example, and I noticed it because it looks like my footage. Your camera was right there on the water, and the horizon was three quarters, 75, 80% all the way up the screen.
Again, I want to find this one, and I'll show you what I'm talking about. It might have been this one. Just maybe going a little too far, too fast. Oop. Might be looking at the wrong footage.
Shrubbery.
Well,
We want shrubbery.
anyhow, I go out there.
We are the knights who say me.
When I'm out there and I'm looking at some of these bird racks that like I said, I've been filming them for years. And it's always, you always see that water at a certain height on this particular bird rack. I'm gonna pop up here.
So I had a quick question for you while you search for a particular piece of footage, and I thank you for searching for the footage, and thank you for all the filming that you've done and that you're showing people. Regardless of what our opinions are, I know personally that it's a lot of hard work going out there filming. Just sometimes half the time you go out there to film, you don't even see what you're looking for, so you strike out. So I know how much work and effort it takes, and then you got to upload the videos and edit and shit. So thank you for even doing that. But my question is, while you look for your footage, what was it about the sun in the concave model that you didn't, or maybe it looks like you found it. We'll address that later. Okay, go ahead.
Well, you see this bird rack right here. This is one it's 3.5 miles away from me, and on a lot of my videos, including when I'm doing filming, the boats, I hope you can see my cursor up here. The boats are usually running on this visible water line right here, okay? And on that visible water line right there, what I'm saying is everything beyond that is kind of hidden, okay? I get this one, or actually I've had more than one day. I've had several days where I've got pictures like this. You can see this bird rack and you see water well beyond it. Now, I put a level on my camera, used the virtual horizon, and found where my eye level would be at the height of my camera, off the water, would have been just above this bird rack, where people say, well, how is that? Because that bird rack is 16 feet tall. Well, because of perspective, right? Things get smaller, things drop because of perspective. We can find that by just looking down a row of hurdles, the farther one away.
Yeah, you can look down a hallway, but that's a very misleading, and it really does fool simple people, because in the hallway scenario, you've got a viewer that's more than halfway. That's more than halfway the height between the floor and the ceiling. You understand what I'm saying? And so, we have a ceiling. We have a ceiling that's 62 miles. Okay, and so for you to use the hallway example, the observer would have to be near 30 miles up in the sky to try to say that, oh, well, these boats are appearing below the shoreline or something like that. It's all because of perspective. It's a real weak argument when your camera is only feet or inches above the water to say, look, you could look down a hallway and say that would happen on, it's.
Well,
it's not to scale, because my camera's 5 inches above the water and I'm looking 10 miles out. Yeah, and so the whole perspective argument is just really, really weak, because it's not to scale. It's not. It's comparing apples and oranges completely.
See that rack?
Right.
Okay, that one's 11.505 miles.
Okay. Well, plus the apparent waterline horizon means nothing. That's just a limit of our vision. There's more water above and beyond those apparent waterline horizons. There's more water above and beyond that. So the apparent waterline horizon proves absolutely nothing about how high the horizon is, because that's going to change based on temperature, the amount of light, pressure, lens booming, all that bullshit we already know all about.
That is correct, 100%, right? And but I've never seen where this water is above this level. I've never seen that. So this is why I can't confirm.
If you could see further, it would. That's how it works with a concave surface. The further you can see, the higher the horizon's going to be.
Yeah.
So your horizon is going to lower and lower as your visibility range reduces and reduces.
You'll never be able to see that the same way that I tell a globe person, right? I said, prove the curve, prove that it's curving down, and they can't. Well, I say, prove that it's curving up, because I can't either, because I've tried many times to prove that something's beyond this this visual, what I see as the level or the horizon and the convergence of the sky. And you can't tell me that you can't see that convergence, because I've got video where I do see more of that convergence of the sky farther and farther out there, it just converging into the floor. I mean,
convergence and perspective are true.
Parallel lines, right? If you look at parallel lines, if you're closer to the bottom line, then your top line will converge to your bottom line, but you'll basically see more of your top line than you are your bottom line, because your bottom line is going to be a little sliver, right? So then that convergence of that top string is going to converge quickly into the bottom string. And that's how, I've been looking at it, is through parallel lines. I've set up parallel lines in my yard, which I've got 2.5 acres, and I've ran them a long distance. And yes, the higher up you go, the less that convergence is, until you get up to where your top line is. And you got to get right smack in the dab of the middle of the two before you can actually really see it. But are you really think you're going to be able to still see that convergence? Because we have a visibility limit, and that's where it ends. I don't think anybody's ever going to be able to see it, 1,000 miles, no matter how good of a camera you got.
Well, apparently some people think they have with infrared, but that's another matter altogether.
Yeah, well, I got an infrared camera.
Also,
I don't agree with some of the infrared footage.
Also, I was going to say that when you're looking at this, like 11 miles or 5 miles, it's compressing everything as well, isn't it? Because really, there's loads of little waves and things and ripples, and it's compressing it, isn't it? Right in, so it makes it only look like it's a small part of, smaller part of the picture.
And swells can also block out, far off objects too. The lower you get to those and the sharper your angle is to those waves and swells, they do eventually start blocking things out. And you can easily prove that by just, at a short distance, get in the water, whether there's a boat around, and get low to the water, and you'll watch the waves, these little ripples coming off your own body, if the water's calm, block out.
Sometimes swells, so you're saying sometimes swells will make it look like convex curvature.
Global curvature.
Yeah, convex downwards curvature, right?
Yeah.
Right. because the water is swelling and blocking your view of certain distant objects, and so a quote unquote globe head would make the argument, see, that's downwards curvature.
Yeah.
But I actually had someone try to tell me that swells were deep. Now that just doesn't seem to make much sense to me now, does it? So if you wouldn't mind, I'd like to screen share some stuff.
Yeah, sure.
There's some things I'd like to talk about the apparent waterline horizon.
I had more pictures to go along with it, but
okay,
that's all right. I'm gonna stop sharing and let you share some.
Yeah, I'm not gonna keep it forever.
Oh no, that's fine. I mean, I'm open-minded. My helper is he's kind of a concaver, and me and him, we discuss it all the time, and we don't have a problem, discussing our differences and even sharing our information.
Sure, definitely. Am I sharing right now?
No, but we're doing the same thing now, aren't we?
Yeah,
We're sharing. We're sharing.
Don't click on your second screen. Click on your first screen. That's what I had to do, and because my second screen is above me, or my screen that's right in front of me, but it hasn't flipped around because once I shared it on my, I have a computer screen, and then I got a TV screen connected to my computer, so I can watch, two screens at the same time.
Can I ask you something, Joshua? When you say that we live in something concave, do you mean the land and everything? Because I can sort of get my head around the water thing, because the water's something different to the land, the sky, they're all different things. We're trying to make it all one when it's all different stuff. But is it the water you're more talking about is concave?
Okay, just let me find one of my videos real quick.
Now, you had the same problem. We only see it down in the bottom.
Well, I was forgetting to click on something. All right, so I can hide this. Where is that? Here it is. Okay, mirror, mirror on the floor. All right. Yeah, flat horizon doesn't necessarily mean a flat Earth. Okay, so this surface could still be concave just because you slap a grid on a surface, prove the shape of the surface. Perspective and convergence could still be true if this surface was slightly concave. Just want to make that quick point. So now I'm going to go over here. Oops, 33 seconds. I must be a Satanist. Just kidding. All right, so here you can see that this mirage, this vessel here is obviously, actually I narrate this, I say the same thing in the very video, but you can clearly see, here's what you were talking about, the waterline horizon, that's our limit of our vision. However, because this is higher, we're able to see it. Now, this vessel obviously isn't flying. It's miraging. You can see the mirage itself has a point of convergence.
Yeah, it's actually being hit.
Right there, you can see where it's converging right there. That's where the water is in reality. Where that boat is, that's how high the water is where that boat is. We can't see it because we can't see that far unless there's a boat there. And the boat is showing us there's water this high. So that means that our apparent waterline horizon doesn't mean anything, and it also shows that the water is higher further away. That's just what we're observing. So I mean, you can take, and this isn't even my footage of this is like 3 feet off the water. Most of the stuff I've uploaded is 3, 4, 5 inches off the water, and you can see clear as day. I mean, if you're going to try to determine the shape of water with optical, the best thing to do is measure the water. But if we're just going to use footage, the best way to do it, obviously, if you're going to try to look and see curvature, the best thing to do is to put your camera right on the water. You should be able to see if it's flat, convex, or concave. And when people do that, the water definitely looks concave. That's just, I mean, that's just.
If you do that and if you're down 3 inches off the water and you got a 4-inch swell,
you can't
a tiny little wave is going to block your whole view out.
Exactly. And that's one of the things that proves that the water is concave. And I'm about to show you that. This camera is really low.
I disagree with.
If this water is flat, these boats should be at the same level. They are not on the same level. If water is flat, then why is this further boat higher than this one? It doesn't make sense.
It's displacement.
You can't say it's perspective because I would have to be like 30 feet up in the air to see this. If water is flat. I'm seeing, okay, these people are standing on a boat. My camera, if picture flat water, see this straight line right here? Flat water. Okay, my camera's, let's say, see where my cursor is? 5 inches. See the height of this above the, now the people on the boat, they're 6 feet tall. How is a camera 5 inches, oh, see this white line, we're gonna pretend that's flat water, and we're looking left to right or whatever. We'll look from right to left, okay? So if the camera is only 5 inches high and the people are 6 feet high, people, my camera isn't at least 6 feet high. Do you get it? You understand it? It's just a logical fallacy. It just doesn't work. The only way this is possible is if the boat is actually higher than the heads of these people. You can't, there's no other way around it. You know what I'm saying?
It's displacement.
Okay, so I'm gonna show you the wave crest that I was talking about. I'm gonna go to a different video. I think it's in my no escape video, which should be right here. Here in this video, I actually made a pretty good Facebook post that seems to have resonated with a lot of people recently. Okay, so this here, there's a certain still shot. Okay, here's a good example. Okay, so you can see here this wave crest proves that my camera is really low. Okay, these boats here are underneath the opposite shoreline. So just like Nathan Thompson pointed out with the Nat Geo thing, right? It can't be curving downwards. My camera is inches above the water. There's absolutely no, and I prove that actually right here. Okay, with a second camera. So you're seeing me film, and that camera is just inches above the water. And what we're seeing is that everything is below the opposite shoreline. So I'm filming shoreline to shoreline, and the boats are underneath my line of sight. You see what I'm saying? The boats are in the concavity of the water, pure as day. Now my camera altitude is lower than a step. That step right there. And so it's not really, I mean, how is anybody proving flat Earth with a P900? I by myself, I've kind of taken that weapon away from flat Earth. There we go. Sorry, I'm not used to this. This isn't my computer, so this is rather aggravating. There we go. Okay. So there's no explanation for this observation rather than the water's curving out. If you really want to know the truth and you're actually thinking about it, if you just want to be right and you're a flat Earth and you say, oh, well, that's just perspective. No. That shoreline's 10 miles away. I'm 5 inches off the water. There shouldn't be that. These entire boats are underneath my line of sight. From 5-inch altitude, I shouldn't see this sand should be the same level as this boat over here, down here. And this sand should be everything should be the same level. Why is this boat that's further away higher? And then the shoreline that's even further away, that's higher. That doesn't make sense if water's flat. And it certainly doesn't make sense if water's convex. It's undeniable. Now, you can say whatever you want. I mean, the right thing to say is, well, we should make measurements. We should take measurements. We should measure not just from one shoreline to the other, but we should take measurement points all along the middle. And if we take measurement points all along the middle, say 3 or 4 different measurement, so that way we get 5 or 6 different measurement points all the way across a lake, preferably ice, or run a laser, all these types of things. But just measuring shoreline to shoreline, yeah, that's great. It disproves the convex ball. Yay, whoop-de-doo. Some of us are done with kindergarten, and we're done, like, disproving heliocentricity. We want to find out what this place is. We're done with the whole false dichotomy trap of flat versus globe. Like, we want real answers. And we're done with the seasons on the flat Earth don't make sense. The maps on the flat Earth don't make sense. The stars on the flat Earth don't make sense. And I know I know you're used to talking with people who haven't researched flat Earth, but I was a flat earther for 2.5 years, and I'm telling people, listen, the seasons on the flat Earth are just stupid. You don't have the sun anywhere on the Earth heating up the whole place for a season. It makes way more sense inside of the sphere, where you've got the sun at the top of the sphere orbiting around the inside of the top of the sphere, creating a summer for the top of the inside of the sphere. And then 6 months later, the sun's orbiting around the bottom of the inside of the sphere. Now you've got the sun in one place for a whole season. That doesn't work on a flat Earth. It doesn't work on a heliocentric Earth. Everything only works inside of a stationary concave Earth with a glass sky and a sun that you see that's not actually there. That's why no one can figure out the position of the altitude of the sun. That's why flat Earth land can't figure out the sun. It's because the Earth isn't flat. It's that simple. The Earth is concave, and the sun you see is just a manifestation. It's not really there. The sun can't be 20-mile altitude with the balloon and right there in the clouds. It just, you can't have both. It just, it's a fail.
But we're talking about the water, aren't we? Because in reality, if you went straight across, you'd go straight across, and then without feeling any like concave bit, and then you hit that land, and then you'll be going straight across again. So you're talking about the water, aren't you? Not the land.
Well, I mean, it's a flat Earth claim that if the Earth is 70% water and all water is flat, then the Earth must be flat. And I'm saying, okay, well, if the Earth is 70% water and all water is concave, then the Earth must be concave. It's fairly logical. If 70% of water makes Earth and water is convex, well, then the Earth is convex. I mean, it's just common sense, no matter which shape you're in.
Yeah, but you're already talking about a few miles.
Yeah, I'm getting insulted here so bad that I can't handle it. Sorry.
I know how you feel, believe me.
Yeah, believe me, because I was where you're at right now, back in the beginning. And see, you were showing a picture of a Mirage boat where I can show you plenty of my stuff where one day I can go out and be at the same height, same camera height, and see that same boat that goes by, or I videotape these islands that are, like I say, they're 4.84 miles away from me. I can get out of my truck and tell whether or not I'm going to have a good day of visibility or a bad day. And then
right.
I mean, some days you can't even see the islands out there. Where'd they go? Did they go up in the air or did they go over the curve? Because I see it as this is it's being displaced by the mirroring. The miraging, the mirroring hides things. It will pull them down. It can pull them up. And
I've always been more medium and will carry your eyesight that way.
Right, and that's and you're showing me those low perspective and saying that the boat's higher in the background. Really, what it is a displacement. In other words, it's pulling that back object up where you can see it, but it is it's not below.
Remember when I told you about the hook and the worm?
It's not.
Remember when I told you about the hook and the worm? Well, you just bit the hook, because if I can't use this as evidence of concavity, then how the heck are you using it as proof of flatness if you have no flat measurements? We're talking about optics here. So if you're going to do my P900 and say, well, you can't, that's displacement.
I've gone out.
We have to take turns. Let each one finish what they've got to say, because it's just blocking everything out, and it just sounds like we're arguing, and we're not arguing, are we, guys? We're talking. Just let everybody finish what they got to say.
Yeah, well, I was going to say, I went out and I bought all these navigation maps and all the bird racks that I film, which are actually beacon marker lights. They're all, I've gone out, I've used the GPS, I've located all their locations, I know their distances, navigation maps that show all their distances. So I do have the distances marked to these. And so, like I say, some days, these objects look like they're sunk in the water, and other days they are right
knowing the distance to the object doesn't tell you the shape of the water, bro. I'm talking about measurements along the, so you can ascertain the shape of the water. I'm not talking about knowing the distance to the object you're looking at. That doesn't tell us whether the water's flat or concave. I'm talking about Lake Zerksky experiment where they ran a laser across, and instead of just taking measurement points on the two shorelines and saying, well, it's not convex, so it must be flat, we're out of here. No, you get measurement points in the middle, and it proves with measurements that the water is concave.
I've heard that before, and I'm not going to argue that fact that some of these guys that are doing it with these lasers are not measuring the center. I believe that center does need to be measured, but also what has to also be measured is wave and swell height, because when we're offshore, right, the waves are different than when we're onshore. I mean, closer to shore you get, you do have what I call it is water tension, right? I mean, you can see it in a glass of water. If you fill up a glass of water on the edges, it pulls up, right?
This is why I recommend doing it on ice, because ice is going to freeze in the natural shape of water. There's not going to be any tides or swells or wind or nothing like that. A frozen lake, not an ocean, a lake, a frozen lake, Lake St. Clair, which is a perfect size. It's big enough but small enough. It's a gem of a lake, which is why Masonic Boulevard leads right up to it, by the way. So running a laser across a frozen lake will tell us, and I will show.
Well, I don't think when I do that, lake would be perfectly flat, though. I mean, the way I see how ice melt. If that was so, all of our ice and our ice cube trays would be, perfectly flat, which they're not.
No, most of the time it's concave. But that's another matter. I mean, what I'm saying is, frozen water is not going to change shape because of the wind. It's not going to. There's no tide. That's what I'm saying. A frozen lake, 10 miles of ice. If the water was naturally convex, then it should freeze convex. If it was flat, it'll freeze flat. If it's concave, it'll freeze concave. That's my point. And if we can measure it while the water is not moving, while it's perfectly still, while there's no swells, while there's no tides, while there's no riffraff, then doing it over ice is really it's gonna rule out a lot of arguments.
Well, if we have tension on
measurements of ice across 10 miles is going to do more for the cosmological community than any P900 zooming along whatever. But I do think it's wiser, if we're going to try to use zoom cameras to figure out the shape of water, at least put your camera on the water, for crying out loud, because zooming across anything from up in the air is just kind of like.
Yeah, have you seen any of Observable Reality's videos?
The only other person I know doing what I'm doing is Tom Hayes.
Yeah, well, Observable Reality is doing it up. I do believe it's in Washington State, on a lake near a dam, and he's doing like 14 miles, 6 inches off the water. I've actually had
the YouTube channel, Observable Reality, because I'll go check that out after for sure.
Yeah,
I want to find other people that are like at least the light bulb turned on and said, "Hey, why don't I take the camera off this tripod and put it like?"
And I have too. I've actually taken.
I know you have, because I saw it in your footage. I saw it.
I've actually had it lower than that. I've actually put it down to the ground with on a high tide where the water was actually coming over the seawall, which was a little scary because I don't want to ruin my camera. But I was
again willing to get it wet, man. I'm telling you.
Yeah, I was still able. Yeah, but I'm in salt water, brother, and salt water and cameras do not go well.
Yeah, that's another problem too. Is the salt water? It gives it. That it's a problem that I had when I was in New Hampshire. I got Hampton Beach right there, so most of my time pretty much all my time as a flat earther was over there. Now that I've got a lake to film at, now I'm ever more confident that water's concave, because now I've got a lake, perfect sized lake. Most of the time you can't even see the opposite shoreline. I would say 7 out of 8 times I would go to Lake St. Clair, I'd strike out. Only on the right days where I had enough visibility to see the opposite shoreline. Now I've got something to compare the boats with, an opposite shoreline. And when I see the opposite shoreline, the boats are always underneath.
Yeah,
always.
Taboo Conspiracy's done some nice work over the lake.
Yeah,
Lake Utah.
he's not. Yeah, Jimmy's buddy. Yeah, I know. Some people are, they're just.
Oh, he's my friend too. I mean,
I was dogmatic too. Hey, as a flat earther, I ignored concave for like years. I was like, oh, that's just another ball or psyop. Gravity's fake, so water must be flat. No, there's lots of. Just because gravity is fake doesn't mean we can't have spherical water. That's just stupid. Hey, when I act like an asshole and I'm condescending, I'm like attacking my former self too. Just know that,
Yeah, well, I kind of take it a little personal, but I said I wouldn't let it get to me.
I'm kind of a jerk sometimes, but
I'm no dummy. I've done my research, and I've also done my own experiments for, well, just for instance, you take a pair of glasses or something, right, and you put it in front of your camera. It usually works better on a cell phone than on a P900 or something, but you can see how things can get displaced and moved.
Cool.
And
it's exactly what proves that our sky is convex from our perspective.
Well, it can visibility, atmosphere. I mean, it causes all kinds of issues. Now, the Glovers, they want to constantly use it's being refracted above the curve, and that to me is total BS.
Right. There's even some flat earthers that are using it to try to debunk my footage. They're saying, "Oh, that's just distortion raising the opposite shoreline above the boats." And I'm like, "Well, wait a minute, but that's the same argument that the globe heads use to say that it's, you know what I mean?" And they kind of got stuck. I kind of trapped them in a really.
Well, see, I've done the low perspective thing, and that's where I do see that actually things get raised up. Matter of fact, I was looking at where I was using wire nuts today, or not today, but I was using wire nuts with a mirror. I made my own big concave convex mirror out of a piece of plexiglass and mirrored window tint, and I made my own, and it really does give you a perspective on how this mirroring effect works over the water, like you were showing where you said that particular area is where the water actually was, and actually I say no, I say it's your it's this effect that's going out there. It's a mirroring effect, and if you actually further and further you get into that mirror, you'll actually turn into a blob and vanish. Which I've seen it on some of my older footage. Where
the title of the video that I showed you actually was called "Mirror, Mirror on the Floor." I don't know if you noticed the title, but that's exactly what I was talking about.
Yeah, the mirroring effect does cause some really big issues, and then if you throw in they call it looming, or it's just magnification for me, because water does magnify things, right?
Absolutely.
Things can get brought in, and as it gets brought in, magnified.
Like the footage of across Chicago there looks just like my footage of Boston. Like the buildings look huge. That's actually true.
Yeah, because
I compare Skiba's footage with my footage all the time, and I can tell what's hocus pocus and what's not.
Yeah, I went out one night on one of the clearest nights I ever had, and actually I had two really clear nights. One was a long time ago where the 3 racks that I filmed from Bayport, they were pretty visible, and you could actually, as it got darker, you could actually see the 3 beacon lights flashing, which sometimes you can only see one. Sometimes I can see all 6 of the ones that I can film from Bayport all flashing all at the same time on a nice, clear, crystal clear night. Well, this particular night, I took my cell phone and literally used my cell phone, put it inches off the water. Now I'm talking inches. You know how high how big a cell phone is. I put my fingers under it and laid it down right at the edge of the water. My fingers were in the mud, and you could still see those 3 flashing lights with my cell phone. And again, the water was like glass out there that particular night. Otherwise, I don't think I would have got it as far as clear as I did.
Right.
And then I also was
Water
doing.
cannot be convex. It just can't be.
No,
because there wouldn't be enough displacement to bring all those things back up over the horizon on a convex Earth.
No.
Right? Light refraction would actually reduce it, not increase. The more refraction would reduce our visibility, not increase it.
Now, I want to agree with you to a certain point too. Okay, because I've always been open to some concavity with Earth. You know, because if you think about a dish, okay, a plate, have you, right? The plate's not perfectly flat. It's concave because it has to be concave in order to hold what? Water, right? And is water perfectly level? No. We have tides. It moves around in it, right? And if you, like me, where I live here in the Gulf of Mexico, if you research how the water comes into the Gulf of Mexico through the Gulf Stream water, right? It comes down on the east coast of Florida, and it comes down and it sweeps around and it sweeps in towards the Yucatan Peninsula, back around Mexico, back around Texas, Louisiana, and then it gets to Florida, actually. And it's almost like a big swirling toilet bowl, if you think about it. And because water is always moving, and I tell people all the time too, that some of the best times of filming, if you're filming where there's tides over, you know, salt water, the best time to film is what we call a dead tide, when the tide's either all the way out or all the way in, and there's a period of time where it just more or less sits there. And it also has to be fairly calm and visibility good. I mean, there's all of these conditions that we have to have in order to be able to see these long distances, correct? I mean, if you've got a bad day of visibility, you ain't seeing very far.
That's what I was saying. I only get one good day of visibility out of 8, it seemed like. So because of that, it seems like things are more distorted when I have less visibility. The more reduced my visibility range, the more and more things appeared convex. Ships would seem to go down hull first, like right away. They'd sail out like 20 feet, and they're already looking like they're going over the curve. You know what I mean? Like exaggerated, but you get my point. But when I can see further, then everything looked concave. That's what I noticed. When I can't see far, it looks convex. When I can see far, it looks concave. Okay, well, what's making it so that I can see far? Clarity.
Well,
that's my point. It's when things are more distorted, it looks more convex. But when things are clear and I can see far, and what's going to give me the more accurate description of what the truth is when things are clear and you can see further. Then you have less distortion. When there's that's the point. That's the point. When it's clearer, when there's less distortion, when there's less distortion from the truth, it looks concave. When there's less distortion, it looks concave. When there's more distortion, it looks convex. Whether he's Jesus or not, Steve's right. When there's more clarity, it's concave.
Well, I've been saying that for years.
I know. I don't think he's right about a lot of shit. Like, listen to it. Listen to what he nuts. I don't even know where it's at. Like, you know. But anyways, go ahead. I'm sorry. I interrupted you. Go ahead.
Am I mistaken that Stephen Lord Christ is? We live inside a bubble with land above and land below.
I don't think his model's like all accurate either. I don't think that's like. His model is close, but it's just another stepping stone towards more things that we got to figure out. And his model is just like to get you like.
Yeah.
Closer.
Well, I have my own because I don't. See, I don't go along with. I don't go by any particular map, Gleason map, the AE map, whatever map flat Earth.
They're just projections.
I am not. I don't know why.
There's a spherical Earth map. That's one thing that the convex and concave Earthers have on flat Earth. We got flat Earth by the balls about is the maps. No offense. Yeah. But I was a flat Earther for almost 3 years. I'm just saying, like, the maps and the stars. I had to say, like, I don't know, but I know it's not curving down. Well, everybody's right. The Earth isn't curving. The water, nothing's curving down. We're all right about that. But at the end of the day, I mean, it's.
Do you know Sam Hancock?
Oh my goodness! Well, I know him probably better than most of you.
Yeah, well, he got blocked out of my channel because he just wouldn't shut his trap. You know, I don't mind somebody coming on my channel and talking civil to me, but when I asked this guy to stop nicely, I asked him very nicely, he tripled up and doubled up and started slamming shit all over my channel. So he got completely blocked.
Sam and I used to be close, and he turned on me too. He kind of like went rogue and went and did his own thing. He's just hating on everybody, and it's really sad. You know, I hope Sam can turn it around, but he just needs to let go of hate, and he just needs to learn to love. And you know, I wish him the best. But yeah, he's going through. He's struggling with some things, and you know.
Yeah, I don't go to concave channels and cuss them out. Okay, the only one that I gave hell to.
I'm here for the science. I'm not here to vouch for anybody else's actions. I'm just going to say
well,
that.
The only person I really had a problem with was Steve himself, because he came on. He told me that he owned my mind and that he controlled me and everything, and I just thought it was a big joke. And that's where
I got to tell you.
I see his deception, so I wasn't buying it, and that's what kind of made
all these things are there to push you away from the science, and that's you know, all these different, you know, I'm Jesus, he's Jesus, everybody's Jesus. Like, it's just like, let's focus on the science. Like, I'm looking for answers about the shape of water, because that's going to tell us where we were like the original creative source. Is it beneath our feet, or is it above our head? That's the skinny of it.
Well, you know, I was talking about.
That's what I want to know. You know what I mean?
Talking about the tension on the edges of the glasses of water. Okay, and you're going to get the same thing on any body of water, right? You're going to have tension up the edge.
Yes, and then surface tension. Water does all kinds of stuff. I mean, we can make zigzag water. The Earth is zigzag. I made a name out of that in research. Zigzag enclosed Earth. Because you can use sound. Zigzag Earth. You can make you can make zigzag water. You can make corkscrew water. You can just look at the who is it? Nigel Stanford, right? The cymatics. You can do all kinds of stuff with water.
Oh
right?
yeah,
cool.
Yeah, and that's, you know, again, that's where I was looking at with this biblical depiction of, you know, the Earth, you know, more like kind of like this Russian.
Oh, right. The firmament, the real Operation Fishbowl firmament. That's another thing that I think NASA and Flat Earth are both hiding. Is the
but it would still be, you're still looking at a bowl shape. Okay.
I'm only talking about a barrier in the sky that's, number one, very close, and number two, parallel with the Earth, regardless of shape. Parallel with the Earth. There's a pressure gradient. The barrier in the sky, which we cannot see, which is fine. Even humans can make. If we can cloak stuff, then the Creator can cloak stuff. Just because we can't see it, I mean, it's not there. There's a barrier in the sky that we can explode shit against, and it's close, and it seems to be parallel with the Earth. And wouldn't you know?
I agree 100% with you on that. That there has to be a barrier.
The firmament is flat too, and there goes half scammers. Bye. See ya.
Well, the all-seeing eye, okay, when you look at the eye, right, it's kind of like got the above and below, as above, so below. So, you know, again,
north, you know, from scripture, the four sides of it, right? Yeah, go ahead.
Right.
The light that exists before the sun, right? Yeah, keep going.
And you even look at the iris of our eye, right?
On the dollar bill. You notice how the capsule is separated from the people on the bottom of the pyramid?
Oh yeah. Oh yeah.
Because that's the original light source.
That's
Lucifer,
what
bringer. You know why Stephen calls himself Satan at the same time?
I have no idea.
I'm sorry, I gotta shut up.
No, but you know, I've looked into this ancient stuff, you know, too, about the shape of the earth, what the ancients thought, and yeah, there's you know, depictions of the flat earth with inside of a bubble, right? Now, if you was to take if the earth was completely flat, right, it wouldn't even hold water, right? Because you pour water on top of a tabletop and it's going to all roll off, right? Am I correct?
No, I still think a flat earth is feasible. If there's an ice wall and you had a flat earth, I don't think the earth is flat. I'm just saying, like, water in a plate, the water will stay in the plate.
Same thing, though. You're going to have the same thing. You're going to have water tension on every continent, on every piece of land, anything that touches.
The water is going to push outwards, period.
It's
because
going to
it's being pushed down from above. It's not gravity. Spherical water is possible because water is being pushed down from above, not pulled down from below.
That's right.
That's where gravity is above our head, not flat earth.
Pressures, your winds, right? Your barometric pressure pushes on the water. Your winds push on the water.
It's etheric pressure. It's a magnetic flux, an up force and a down force. That's why buoyancy can see. Flat Earth can't explain it. Flat Earth just says, "Oh, density and buoyancy." No. There's forces making the shit go down.
Not all of
like
no, they're
Blinky. When Reservoir Booty did the whole Blinky thing, remember? That proves that that gravity's bullshit. There's no singular pulling force pulling down. Otherwise, smoke, steam, nothing would rise if gravity were true. It's just
you see that
like
video. You got that
stuff
video
being put down from above. That's all it is. That's gravity in the nutshell.
Did you ever see a video where they got two glasses of water real close to each other and they, start throwing electricity into it, and the water is actually jumping from one glass to the other? I mean, it's like makes a water bridge. Have you seen that video? Some guy was doing an experiment with water and static electricity, and and he's got some really good examples of this. And these are things that I look at too, because I think Earth is electric. And so is our sky, right? Our atmosphere is also electric.
It really is. It's electric magnetism. It really is magnetism.
Yes. And Ken Wheeler, he brings up some interesting facts too. Even though he's still a glober, right? I mean, he believes in the globe, but he talks about this inertial plane, and
don't confuse unless you believe in the globe,
right? And he talks about the planets, and I've seen him several times, and anytime I mention flat Earth to him, his little fanboys start jumping all over me. He'll never be a flat Earth.
They know it's convex or concave, and they know it's concave. But they have to. But that's why heliocentricity exists. It's just an inversion. That's why the maps. That's why none of the. Look at the video. I think I entitled it "Concave Earth Challenges Awake Souls." Okay, like the UTM map is accurate, and it's a spherical Earth map. Look at Cass Kring's Pinterest. I can link it to you if you want. Over 700 concave Earth maps. Like, flat Earth doesn't have that much history. 700 concave. You'll notice there is a difference between convex and concave Earth maps, and that's why the globe maps don't work. It's because the Earth isn't convex. It's concave. That's why the flat maps aren't even close. They're just time calculators.
Well, I'll look at your channel a little bit more if you've got information on it. But
I explain why all the different flat Earth different. There's you got a diamond projection, you've got a circular projection, you've got square, you've got rectangular, you've got the teleporting Pac-Man stuff, you've got
Let me stop.
like, I have another video entitled NASALies.org destroys flat Earth. We go through all different.
Can I say something?
There's a bunch of different flat Earth models. There's not just one, you know, and none of them work.
Can I say something?
As a flat earther, I tried to figure out which one it was, and it's none of them.
Can I say something?
Absolutely.
How do you not know that it's the cameras doing this effect? Because it's already compressing the water.
Yep.
Now, the camera is also doing something. It's the water.
That's why we need to do more low perspective on a smaller scale too, like I was doing with my camera and a mirror.
The fishing line experiment is a perfect example. Exactly what you're talking about. You run fishing line you got to get fishing line that's the same exact density as your water, so it doesn't so it's buoyant and it doesn't rise or sink. And you run that tight line across the surface of enough water, and you should be able to take measurements all along that. You're running a tight fishing line submerged in water. And there's actually a place in Spain where they have a bunch of different irrigation straight water canals, which is perfect for this experiment. But you just run a tight fishing line that's equal density as your water, and you literally just measure all along the way. And if the water stays parallel with the fishing line, water's flat. And if it's not, you'll be able to tell if the water's curving convex or concave. So the fishing line is a great, inexpensive, difficult to accomplish. People have tried it. You can find it's called Torque the Line experiment.
Yeah, I've seen it.
Where the line wasn't as strong as the specs claimed, and the line kept snapping, and so they couldn't complete the whatever, blah blah blah.
Yeah.
But at least they tried, a failed attempt, but that's what needs to be done. We got to start taking measurements, period. We can argue all day long about the, distortion and camera, blah, 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 blah. Unless we start taking measurements, hard measurements, whether you're using a laser, fishing line, something. But if we're going to use optics, obviously getting as low as you can is the smartest thing to do.
Can I say something?
You know what I mean? We got to figure this out. Obviously,
Can I say something?
Have to be spherical based on the maps, and it's not. We're not on the outside.
Can I say something?
So easy.
Can I say something? In the UK, Dave Marsh did a test from Shoreham over to Brighton, and it was about 10 miles. What they did was they wanted the tide to be out, so there was a lot less water. But when they did their laser test, there was no curvature, no upwards, downwards. It was straight across. But they took most of the water out of the equation. They did it on a very low tide because they wanted to go from land to land, but where water would have been. It was flat.
But I want to know, how did they know there was no upwards curve? Did they measure the middle?
Yeah, it's. I'll have to find it for you.
I'll
send you the link afterwards.
In the middle of their laser experiment, I want to see those results. Measuring, at one end and the other end. Okay, well, you shouldn't be able to see that on the outside of a ball. Okay, yay, we don't live on the outside of a ball. I need to know the measurements in the middle, because I already know it's either flat or concave. But for many other reasons, I already know it's convex or concave. The only common...
Yeah, but I said at the beginning, though, we're trying to treat everything as the same thing. And I just think with the sky, the earth, and the water, they're three different things. And then we're trying to deal with it all as the same. And as Wideawake's saying, the effects it causes and the mirroring effect, and the fact that he knows that even though his camera's compressed it all, there's miles and miles more water. We're trying to deal with it all as separate. And I I was explaining to people, right? If you understand, I've said it a few times. I just want to say this little bit, but it's not really about water. It's about land. But we've got the White Cliffs of Dover, right? And then obviously they're above that there. If you drive from that area to here, there isn't really many hills. And if there are, they're tiny, yeah? And then when you get 10 miles past me, there's a big hill down. And then a few months ago, it made me realise that we're living up here and they're living down there on a plane.
We're never going to know the shape of the earth by measuring the land, by measuring the dirt. We got to use water.
So they never explained to us that we're actually living on top of the hills here on a plane. And then you go down that hill, and then Devon and Cornwall and all that out like towards America, the foot of England, they're all living down there. They never show that, do they? So what I'm trying to say is maybe we don't understand everything in this place that we live. But I mean, it is a bit crazy. But I'm just wondering, you know, if you've watched Enslaved by Mo Media, he's reckoning that cameras are lying about the real, you know, distance. And that,
one thing I do want to back him up on a couple things. For some reason, he blocked me, and I've been nothing but cordial. I think he did unblock me. Whatever. Two things he's right about. The one, the gasoline hoax. I mean, and you know, and the vortex engines in the airplanes. Number two, the P900. That is true. And you know, and Wide Awake, you might back me up on this. You'll notice that I've got to zoom out, you know, a good, I don't know, at least 20-25% on my P900 just to see what my naked eyeballs are seeing. So there is like what I call the P900 when completely zoomed back. I call it, you know, I call it negative zoom. It starts with like a negative zoom because I gotta zoom in. I gotta zoom a little bit just so that it matches what my eyes see. So it is kind of misleading as to how far you're zooming out, because when you zoom back, I mean, it looks like I'm 30 feet behind myself. You know what I mean?
I will back that up. That is very true with the P900 and the P1000 and the B700. Most cameras do that. Even with your cell phone camera, it does it.
Sure.
So
maybe it's because it's a smaller lens. Like literally the camera's eyeball is smaller.
So when I zoom back and it looks like it completely vanishes, it does, right? Because if I zoom in just a little bit on some of my boats, I still cannot see it. And I look up with my own eyes over the camera quite a bit. And when I look over the top of my camera, right, I'm actually looking higher than my camera, of course. I mean, I've even stood up where I've had my camera down real low to the water, right? I've stood up to try to see if I could see the boat, and no. And again, like I was trying to tell you before, there's a where I film at, there's this little observation deck, right? And that observation deck is maybe 3-4 feet off, not 4 feet, about 3 feet off the sand. And then of course, if you go up there with your tripod 5 feet, you're going up an extra 9 feet. Now, I've been up on top of that deck, right, and filmed those islands, those Hernando Beach Islands, 4.84 miles away, and they were cut off. They were like, and I've seen them on some days where they weren't there. Again, they weren't there.
Yeah, I got so tired of using the ocean because you get like, I mean, it's number one, you got waves and you got tides, and so we got to start using fresh water. I mean, this whole salt water was a huge problem for me. Yeah, wow. So I think it was a smart move for me to come up here to Michigan.
I don't have that luxury of finding a lake big enough where I've got.
I didn't either. In New Hampshire, we didn't. I mean, we had Lake Winnipesaukee. That's like 26 miles. I'm sure I could have found certain spots on that lake where it was like the right distance comparable to Lake St. Clair over here. But this Lake St. Clair is dynamite because it's no matter where you are on the perimeter of the lake, you get dynamite footage across the lake from you. And it's like U.S. and Canada, like half the lakes in Canada. So
where I am at, I do have an advantage.
I have to sneak in with a kayak.
I am not on the east coast of Florida. I'm on the west coast, which, you know, in the Gulf of Mexico.
That's better. You get some nice sunsets, right?
Yeah, where I'm at too, you get we get some really nice days where there's no breeze, there's no wind, and I mean, you can see it in my videos. The water it's like glass. I mean, it just mirrors the sky out as far as you can see. So I always look for those days, and those are the days where if I get a very calm day and I also have very clear visibility, I mean, this is when I'm catching my 11.05 mile bird rack at 28 inches off the water. I have a back issue, so when I get down much lower than that, it's very hard for me. Number one, hardly can see the damn camera. Because, you know, if you got it laying almost flat on the ground, like the day I had it on a towel sitting on a little 2x4 on the ground, number one, I had a hard time actually even, you know, working the camera, moving it, finding my target. Number two, I'm like stooped over, and it's just not good for me. But I like my area that I film in.
10 seconds and make a suggestion for you. I have a solution that will really help you. That you're not going to like this, but it's the best logical thing. All right, just walk. Just get some swimming shorts on. Nothing on your feet. Take your shirt off. Put your camera in your hands with two hands. Put your camera in your hand with two hands, and never take your second hand off the camera. And walk into the water, belly button high, and film. And you don't have to do any crazy acrobatics. You can just be standing up, filming.
I've done it.
Just like you're
Right.
some dirty cops. So it can be the same thing. You're just getting your eyeballs and your camera right on the surface of the water. Like make the water high or whatever you want, and you can just skim along the water, and you'll see that water's curving up. I promise you.
Yeah, well,
Get in the water with it.
I've done it before, but you know, there's also crabs out there, and I really don't like having my toes pinched by crabs.
Oh yeah, I know. I have that. I'm sorry. I have that luxury of having a lake.
Yeah. But no. Now, too, when we look at these, you know, you say I get a lot of nice sunsets, and I do, and I don't call them sunsets. I call them sun departures.
They're actually sunrises. When the sun's appearing to go down towards the water, it's actually rotating above your head, up and away from you. The actual sun is.
Can I say something? Can I say something quickly?
And you're the host.
Looking at Wide Awake's footage, right, because he came onto the channel and he was talking up and showing us the sunset. Well, a departure. And what it was is, at the point you could see in the water that what looks like, well, we'll just take it that it's supposed to look like the reflection of what's above, right? And it's a semicircle, just like the sun going down. And well, I know it changes. I know it can change shape and go hexagon like or whatever it is, and then it goes green and poof.
The green arc.
What it was is because I slow footage down on my other channel, I just wanted to look at what he was looking at because you could see through the sun at the same time. Wide Awake was showing us that you could see at that low level, that time of night, you can see through the sun. But what it was is that this wasn't a semicircle in the water at all. Actually, when you slowed the footage down and you blew it up a bit, you could see that all you were looking at was the corridor effect. It was a corridor to the sun.
Right, the omega symbol.
What I mean is there was no curve. Everything was straight. And the corridor at this point in the water goes straight to the sun. But when you're looking at it, filming just from that camera point, it looks like it's a semicircle. But when you actually blew the footage up, it was a corridor, a straight line, straight to the sun.
Yeah, I've got some really, really good ones where
Here's a straight line to the sun because it's whether it's flat or concave.
Well, I can.
Yeah, but these lines were straight to the sun.
Right, because you're always going to have a straight line of sight to the sun. It doesn't prove the surface that you're standing on.
Yeah, but they weren't in the skyline. They were in the water reflecting. Reflection. It was on the in the water. It was reflecting to it. What I'm trying to say is, I'm not arguing or saying anything. What I'm saying is,
I guess
when you look at it,
see what you're. Until I see what you mean, I guess I can't really.
It's on Sun and Moon. But what it is it's on Sun and Moon with Wide Awake. But on his, I even used it in another video as well because it blew my mind that from one perspective, like the camera straight out, it looks like a semicircle in the water. When you actually zoom in, there's no semicircle. It is just straight lines, which give from a distance this appearance of a semicircle going up. Straight lines. I was gobsmacked.
Can I say something here? This is why I stay open-minded still. I do call myself a flat earther because I consider myself like the pig in the middle. Okay. I call myself that, but
I know you don't like the label. It's cool. I get it.
I'm open with some convexity. I really am. Because I feel like there very well could be some kind of convexity that's well with not like what I mean, like outside of my realm of vision, right? Okay, I cannot see where the sun goes when it goes to this certain point, but I also don't see it. I don't see it going up, even though I saw some guy do a video.
You're not going to see the sun go up in that
No,
model. Your view of the sky is inverted. That's why it appears to set, is because it's actually going up.
Well, actually, it doesn't set. It just goes in over land. It'll just go poof. 1 minute it's there, and the next minute it isn't.
Yeah, Earth is huge. So, of course, we're not going to be able to see 1,000 miles. Okay.
Plus, your sun, that's not the actual sun anyway. Nobody sees the actual. That's the whole key to this.
That's true.
That's one thing that nobody understands, and they think they have proof that the concave model is false, and it's simply because they don't understand the sun. If they actually understood that the sun that they're seeing is not actually there, then they're using the sun to debunk concave Earth.
You shouldn't be saying that the flat earthers aren't looking at that, because they have. I've seen plenty of videos with flat earthers showing that the sun isn't in the actual place that we're actually seeing it. It is an image or a mirror or a projection of sunlight.
I think most flat earthers believe that.
Yeah,
we're looking at not looking at the real sun.
They've taken lasers and shot them through, glass and mirrors.
Right, the same flat earthers will say, well, if that were the case, we'd see the sun going up in the sky. It's just.
No, I have seen somebody post one, and they were a concaver. They posted the sun vanishing, and then they show this what looks like a star going up in the sky, and I'm like, that's not the sun. I mean, that's, to me,
it was probably Cass. It was. I want to plug a channel right now called Rethink Everything. He's also in Florida. He's also on the West Coast.
I know Cassidy.
I know. I know you do. You have to.
Yeah, and me and him discuss flat Earth and concavity all the time. So
I was living in Georgia at first for about a year, and on my journey up to Michigan, I decided to go down to Florida to meet some people, and Cass was one of them, and so that was really cool. He's a really lovely gentleman. We had a great time, and I highly recommend you look at all the work he's doing with light right now, because he understands what I understand with the light, and just a lot of this, quote unquote Illuminati Masonic symbolism is simply based on light passing through glass.
Yeah, he's done great work.
For Waters, I love you. I get it.
Yeah, and he has shared a lot of the stuff that he hasn't even put on YouTube with me.
I know.
So, like I say, I stay open-minded. He stays open-minded, and we can have discussions about it without.
None of us are stuck on a model. You know what I mean?
It is ego. A lot of ego is in the way.
Absolutely.
So if you take the ego out and just stay open-minded, like he understands my position, where I tell him I'm kind of like the pig in the middle. He understands my outlook on that. And he also sees some of my videos and he says, really, Dave, because you do make me think about things, because I share stuff with him that I haven't shared on YouTube. And I have a lot of my little experiments that I've done, I've never shared with anybody, except for maybe a few of them with Cassidy. And, he agrees that, he thinks that, we all need to step back. And he thinks, and I agree, I think also that instead of working against each other, the concave people and the flat earthers should be working together, not each other up. Because
I agree. However, but I do want to make people aware that there are some flat earthers using that excuse to hide what they know. There's certain things that certain flat Earth proponents don't want to talk about. Okay, and so those, I'm not naming anybody.
Joshua, maybe it changes today. Maybe it'll change today with you two talking, because hopefully many people will watch this video.
Area in the sky then.
Yeah, but maybe many people will watch this video and it will change people's minds, because we're still at the talking stage for most things. You can only change yourself. Right. You know, that's the one thing you can change. But at the moment, we're at the talking stage with most other things. And it's good that we have these conversations, because no one's got the answer yet. I mean, even if we do the water and the land, like, what are we in?
One thing we do agree on, it ain't a ball, and we're not living on the outside. I mean, it's not an outside.
Yeah, we're not spinning.
We're definitely not spinning. So hey, love's the most important thing, and
That's
you know,
right.
We're obviously not spinning, regardless of shape. We're not moving. The sky's moving, so we're all good there.
Yes, and we know we have something covering us, separating us from outside, whatever is outside, right? So
which is probably parallel or somewhat close to parallel with the Earth.
Yeah, I call it like
it might breathe. I think the Earth breathes. That's why we have like
the lens of the eye. You know, we could be in God's eye. We could,
our barrier breathing. It's extracting, and I think actually, quite literally, I think the altitude of firmament, which is basically just a spherical glass within the Earth, 62 miles above the surface of our heads. I think that breathing is what causes the tides.
Well,
in conjunction with the magnetic.
I've got a better idea about that one, Joshua. I'm gonna have to find the name for you. He's a really great guy. I actually mirrored his video. It's just another form of electricity in the water, because we can get in the water, but it's a different dielectric electricity, and as that's happening, it's causing the waves. It's in the water. It's electricity. It's another form of it. We don't know everything. It's just immense, this place we live.
Well, water is diamagnetic, and if the physical actual sun is metallic and magnetically orbiting around the celestial sphere with the rest of the planets, right? If you planets, for lack of a better word, so wandering stars, right? We know things work off of magnetism. We know orbit is possible through magnetism. So if the luminaries in the sky are all working off of magnetism and water is diamagnetic, then it's not just any one thing that's causing the tides. It's a collaboration of many moving parts causing the tides.
Well, that's the same way.
Our tides is a result of the whole celestial mechanics. It's not just the sun causing tides, or it's the moon causing the tides, or it's this causing tides. No, it's everything.
It's a combination.
Breathes and
listen, we haven't even understood that the sun is moving at one pace, the moon's going another, and sometimes it goes fast, slow, and so does the sun. And the stars are also moving. Stars are also moving at their own rates. They're different. They're all different timings, different things.
3 hours, 56 minutes, and 4 seconds is a sidereal day, which is a day for the stars, basically. So the sun moves at one speed, the moon moves at another, and the stars move at a third. All of that works inside the Earth.
Here's one thing that you can do too with the sun. You can measure the mirroring effect that occurs. And that's one thing that I've got a lot of.
So we can't really know what the sun is doing. We never see the actual sun. We only see the apparition of it. So yes. It makes it incredibly difficult to know the actual position of the sun, because nobody ever sees it.
Well, what I'm saying is what we do see, you can measure that mirroring that's above that visible water line. And that's what I was trying to say was, on some days, the sun gets close to that horizon, and man, all of a sudden you see this big, large amount of reflectiveness coming back up and meeting with the sun. Okay. And that's, and then other days it's just this little sliver. Other days it's bigger, other days it's smaller. And that's where I see this mirroring effect occurring over the water. And now you were saying combinations of these effects, right? All these different causes the tides, right? Well, put that towards our observations. We have all kinds of optical effects that are actually occurring too. And mirroring is one of them. This mirroring effect does, cause you to see things completely different than what they actually are. The angle of light too is also another thing. The amount of light coming in on one angle to where you're actually observing, because I've actually watched a boat come in offshore as I was tracking it.
I see it as I cut metal. The deflection of light by matter is well observed.
Can I add something into the mix very quickly?
You're right. Any atmosphere can deflect light and alter your perception of where something is. Just like a straw in a jar, or a fish in water that you're trying to stab with a stick. You throw that stick in the water, and the fish is in a completely different spot than you thought it was, because the water is displacing the object that you're looking at. So I do resonate with what you're saying. Yeah.
Exactly. Now now I'm tracking this boat, right? And this boat comes in. It looks like it's over the curve, right? Where I know in the mirroring zone, what I call the mirroring zone. It comes out of that. It comes into perfect visibility. The boat not only goes from being small, it goes to being big, and you can see the boat completely in the water. Now, as this boat gets even closer to me, I show it in one of my videos. You can see this mirroring line. And all of a sudden, this boat starts sinking into that mirroring line. Even though it's bigger, it's closer. Now, all of a sudden, it's vanishing behind this supposed what Glovers call a curve. And I'm like, now how can that be? That it's out here, it's small. Then it gets into where you can actually see the complete boat in the water, and then it gets on another angle, and then it goes into this mirror when the boat's almost taking up the whole screen of my video. It tells me that these optical effects are they're real, they happen, and I think it's the light, the angle of the light, that causes certain mirroring effects.
I also believe, like Cass does, that sunlight is reflecting off the surface of the Earth back up, which is why we get anti-solar horizon rays that come from the horizon up over our heads. You know what I mean?
Well, I've got lots of anti-corpuscular rays videos.
No, anti-solar horizon rays. I'm saying the horizon opposite the sun has rays coming from the horizon up over the head, over our heads. But the sun's not even over there. Those rays can't be coming from the sun because the sun's 180 degrees behind you. Anti-solar horizon sun rays, which is only possible if light is reflected. Is reflecting off the surface of the Earth back up towards the sky, and you're seeing that beam of light you're looking at isn't coming from the sky, it's coming from the Earth back up towards the sky, because a beam of light is reflecting from the sky off the surface of the Earth, and you're seeing the beam. You see what I'm saying?
That's what I say lights the clouds up from underneath, is reflected light reflecting off it can reflect off of Earth. It can reflect off of water for sure. So when I see these clouds light up red in front of me, all right, they're saying that that's getting hit directly from the sun, the globe people, right? That the sun's dropped below the clouds to shine on the bottom side of the clouds. See, I don't buy that from them. I always say, no, it's reflecting off the water and bouncing back up to the sky. Well, light can't reflect that far. Well, my God, they want it both ways, these Glovers, They want to be able to say that the sun's 93 miles away, reflecting its light to Earth, but it can't reflect the light back up to the clouds, right? They totally contradict themselves most of the time, these Glovers, and that's why I kind of laugh at a lot of them.
That's why you think I'm such a jerk, because I
understand where you're coming from. I'm saying a Glover. No, I have not insulted you one bit. Matter of fact,
no, you haven't. No. But that what I'm trying to say is that's why like you said, sometimes so we all laugh at the globe heads, right? How stupid they are sometimes. Well, I do the same thing at flat sometimes because of and I'm not like trying to condescend because I have to laugh at myself. I have to laugh at myself. I was a flat earther for 2.5 years. That's embarrassing. Now that I understand what I understand.
You ever see the sun come down and go flat on the bottom?
I'm sorry.
Every
single thing flat Earth has to offer.
Have you ever seen the sun come down to the horizon and flatten out before it even gets to the horizon?
What do you mean by flatten out? The sun always looks like a flat disk, but I don't know if you mean like flatten out like we could look at the thinness of it. I've seen footage of the moon where the moon, high altitude balloon footage, where it just looks like the moon is like a flat disk of like a wafer. Like it's
well,
weird.
I've caught this.
Like the moon and the sun are so interesting in each in their own ways. It's amazing.
Can I say something? Can I say something?
It is. It's perplexing.
Can I say something? In the morning, right, due to my perspective, I can't always see it, and it depends where it's coming up in the sky, you know, from summer to winter. But when I do see it sometimes come up in the morning, probably more the winter ones, because it's through this gap in these houses, you can see the sun actually can come from a long way. When I go the other way and I go to work and it's setting, right, Newbury's in front of me. As I'm driving there, I can see the sun. And yeah, I might have been in a little bit of traffic. And by the time I get there, the sun's gone. It didn't go anywhere. It just vanishes at a certain point.
Yeah,
it was just there over Newbury. It was quite big, quite high in the sky. Then these few minutes happen. And then, you know, you think, oh, where's it gone? I'm at work now. Oh, it's gone.
Well, one day I'm going to have to sit down and just do a barrage of sunsets so people can see the difference, the way the sun reflects off the water and how some days it doesn't, and how, you know, when I get a good day of visibility, it does something completely different than normal. And it also not only does that, but if you, like, you know, they tell you when the sunset's going to be, when it's gone, and all of that. You know, I got an app on my phone that tells me that. And here I'm sitting here watching this sun that was supposed to have already set, but it doesn't actually look like it sets. It looks like it turns sideways and goes flat on you.
Right.
That's, you know, when I look at that, you know, I have to ask myself, is this, you know, more of a optical illusion, or is this really what I'm seeing?
From the perspective of a flat earther, they're always going to see the sunset as they're always going to see that water is ramping up. It's a flat surface ramping up due to perspective, and a concave earther is always going to see it as that water is curving upwards because the surface of the water is curved upwards, whereas the flat earthers see it as flat water that's ramping up due to perspective.
No, I don't say it's ramping up due to perspective. I say it's ramping up due to it's not really when we get some of these mirroring effects, it's not really mirroring off the water. It's mirroring off of the atmosphere above that water. Matter of fact, that's why I was talking about doing my little test with my ear.
Right? All right.
I'm squirting water down on the concrete.
Hang on.
I'm sorry. I'm squirting water down on the concrete to get, you know, some evaporation rate going, and, you know, I can actually see the concrete behind my mirror get literally stretched up and out. And that's where I say, you know, there's these optical illusions. Even on some of my pictures, I say that there's an illusion going on it because they do look like they're getting like stretched and pulled up. And that's where I'd say, well, is this getting displaced? So I do my little test with my mirror, and I see the same thing in my mirror. So, you know, I just keep myself where I'm asking the question, is this what, you know, I'm seeing? I'm pulling something up over the curve. But then I have to ask myself, well, how can you pull something up if your camera can't see it in the first place, right? I mean, if your camera cannot see an object, then it's not going to get pulled up. So it has to be your line
right.
of sight, right? It has to be within your line of sight before your camera is going to stretch that image out or squash it down, right?
It's got to be within your plane of sight, right?
I see compression, I see stretching, and with in these different optical effects that we get. I mean, especially compression. I see compression a lot.
Convergence. Convergence is a perfect example of compression, because anything will appear to compress the further it goes away from you because of convergence in perspective. It's going to appear smaller and smaller, which is compression. If something compresses, then it appears smaller. Well, that's one and the same thing. Zonular accommodation, zonular compression is the same thing as something appearing smaller and smaller due to perspective.
When you think about distortion, man, can you focus on distortion?
Focus on
I had a guy telling me that all my
that's kind of like the tongue-in-cheek I did with my last Facebook post about seeing stars in the water,
So I recently had a Glober come on my channel, and he's saying that all of my bird racks, everything, all these boats are superior mirages. And I'm like, how can they be superior mirages? I track them from right in front of me, right? I mean,
they're not.
I track this boat. It's going out. It's 50 yards from me, not even, right? I mean, I'm standing at the boat ramp, and I follow this boat out, and the boat keeps going and going and going. And the boat, I'm just watching the boat get so small that my camera can no longer even resolve it. And they want to tell me that it went over the curve. They say, no, it never went over the curve. It just got so small.
A hub of water. Only for several reasons, the Earth has to be flat or concave. We can't be looking through a hub of water. It's not possible.
No. I mean,
light diffraction, distortion, lensing, all that stuff. It reduces your visibility range, the increased distortion. So it means that the convex Earth explanation for why we can see so far is wrong. It's reversed. More distortion reduces your visibility range. It's only clearer further, with less distortion you can see further. With more distortion you can't see as far, which disproves the convex Earth explanation for why we can see so far in a convex Earth. It's false. The further you can see is because it's clearer, not because it's more distorted.
Right. And I'm always telling these people,
which means your horizon is always higher and higher and higher the further you can see, because there's less distortion.
Yeah, visibility is definitely the key.
The very reason why the convex Earth explanation is wrong is because it's the opposite direction. The curve goes up, not down. The very reason why that lie exists is because the Earth is concave.
Can I say something, Joshua?
Earth is just in the middle. It's a stepping stone. It's half truth.
Joshua, you know though, don't you? When we were talking before, you did say that not everything is right with being everything with concave either. So not everything's right with flat Earth, not everything's right with concave, not everything's right with the circle map or a square map. Nothing's right so far, is it?
Nothing's right
we haven't got everything right. We haven't understood it all yet.
I don't think Steve's model is 100. I do think there's holes at the poles. Number one, I don't think they're hiding Antarctica because the Earth's flat. They're hiding Antarctica for many reasons.
Well, I was on a hangout last night, and the way this person drew their map, it could have been that there was a lot more land to the east and west, and they've concentrated us on the north and the south when actually the land was east and west. But can I say we've been going for nearly 2 hours, right? Can we just already? Already. Can we have a few minutes each, because we could go on forever, and maybe you want to come back and talk about it again. Do you want to you started, Joshua, and then Wide Awake say something. Anyway, go on, Joshua.
Well, maybe next time we can talk more about the sun. You know, we spent a lot of time today talking about the water, which I think is a great place to start. The shape of water, number one. So that's no problem there. But I think maybe next episode we talk about the sun, and when you try to ascertain the altitude and or position of the sun, you'll realize you're not seeing the actual sun. And so once someone realizes they're not seeing the actual position of the sun, then they're going to progress away from the false dichotomy. And so it's going to help a lot. And and that in conjunction with the barrier in the sky that must be parallel with the Earth because of a pressure gradient, those two things together, in collaboration with hopefully my and several other people's observable evidence that it definitely appears that water is either flat or concave, and the spherical maps of the Earth definitely indicate that the Earth must be either convex or concave. So, you know, that's I'll just leave it at that. And thank you, Karen, for having me on. Thank you, Wide Awake, for, you know, everything you've done, and thank you for joining us. And, you know, I'd love to talk again.
Yes. I just want to say, people who just keep your mind open, look at both sides. Don't get stuck on one. Be open, and keep doing your research. If you have the possibility or the capability of doing your own observations, please do so. And don't just do them on, you know, here and there on days where you've got this bad mirroring effect or bad atmosphere. Try to get out and do it through a long period of time.
About sacrifice, you've got to be willing to sacrifice.
Yeah,
if you're not willing to sacrifice, you're not going to find the truth. You're just not.
And then take your own footage and search it. Look for those small details. You know, there's all kinds of little details in your videos that are very telling. And if you pay attention to those details, you will start learning, you know, number one, it can't be a ball that we're living on the outside of. That's where I'm going to stand at. I am going to say, though, I am still the pig in the middle. And I will probably stay that way until I get convinced, or I can convince myself, because that's who has to do it, me, not anybody else, of something different.
I respect that position, by the way.
Yeah, but you know, keeping that open mind is the key, because I think once you close off any side, I mean, even the ball side, okay, you got to keep that in mind, because once you close it off, then you're just going to close it off to one side and one side only.
Yep.
And you know, everybody does. A friend of mine says this: everybody wakes at their own pace. So wake at your own pace and trust yourself more than you trust other people, that including myself or anybody else that you see on YouTube.
Hey, thank you very much.
Well said.
Thank you very much for that. I also feel that we need to stay open. We don't know everything. Nobody knows everything. Still, sorry, not everything, but a lot of things are still theories right now, even for us. We know we're not spinning in that. We know, our senses tell us, but we don't know everything. So we have to try and learn from each other and grow as a community, because it's, you know, pretty dire out there, isn't it?
Exactly, Karen. Yeah, learn from each other for sure.
Yeah, anyway, so we're ending as good friends, and we want another talk, so that's really great. Thank you so much, Joshua. Thank you so much, Wide Awake, for spending this time with us. And
I wanted to say thank you to Josh too. You know, I'll have to check his channel out. I'm sure Rethinking Everything will give me a link to your channel, so that'll be good.
Oh, you'll find it easy enough. Zenith Atlas, you'll find it. Okay. And I'm gonna look at more of your information too. I was checking out some of your stuff for the past week. I was looking at some of your videos, and so, you know, I get it. Hey, I understand. You know, I've been there. I've done that. I've been doing it, and so I get it. So I just wanted to let you know, like above the shape of water, like love is the most important thing. Like finding our source of creation is monumentally important. But if we can't love each other in the process, then what good is that knowledge if we're not gonna utilize it properly? So love is of utmost importance. So we have to remember to love each other. Otherwise, the knowledge is useless if we're not going to use it.
I already subscribe to you, Josh.
All right.
Yeah, I haven't been getting. It's really funny. Well, I'm sure you've noticed too that notifications are very slim to none on both sides, right? On flat earthers and concavers, we're getting like censored and shunned by YouTube.
Of course, they're gonna censor anything that leads to the truth. So it doesn't.
You know what? You know why that is, don't you? It's because Google owns YouTube.
Right.
Google owns YouTube, and look what we're talking about.
If they only censor the truth, then it makes it obvious what the truth is. So they have to censor residual truths or things that are close to the truth or things that lead to the truth or anything that would raise questions that would lead someone to the truth. They're going to have to censor all of that. So they're going to censor flat, they're going to censor concave, they're going to censor hollow, they're going to censor video game earth, they're going to censor zigzag earth, they're going to censor anything except heliocentric earth.
That's it. That's their goal.
Fuck it all. The earth is a spinning ball in outer space, and aliens are going to come kill you. So that's the narrative, and they're going to censor everything else.
Yeah, let me say this again too. You remember a year ago, you could click on a say a flat earth channel or a concave channel, and the next video up would be another concave or a flat earth channel, right? And you could sit there all day long and watch flat earth videos or concave videos.
Hey, that was 2017. It's not like that anymore. All you're going to see is gatekeeping from the History Channel and
I mean, that's all I can do anymore.
Rhetoric, ISS, which my fucking geese footage debunks his ISS transit. Get out of here.
Yeah, his ISS.
One thing they do is they put a Wikipedia thing up talking about it used to be, like it's this is the way they used to be, but
what they won't show you is any concave.
eBay did the same thing as this. eBay changed the search system a few years ago, about 6-7 years ago. It completely changed everything for everybody. It's to make room for the big business. It's always to make room. eBay did this
in the last 1 year. Just a year ago, I could type in flat Earth and find Dubai and find
because they changed the algorithms now. They've changed everything.
Now all I get is Jewish flat Earth. I don't get grassroots flat Earth anymore. When you type in flat Earth, go.
Yeah, because flat Earthers and all that are not.
Space EATRH enter. You don't get grassroots flat Earth anymore. You get.
I made a video about this on Unscrambled. They've got Joshua.
Is flat Earth, but I know they're censoring the shit out of it.
Joshua, they have an algorithm, and what it is this guy. He was looking at the gobbledygook in the back of someone's post, and he could see that it's all written into the algorithm. So YouTube brand you which algorithm you are, and you'll never get out of it. So they brand all the people like us on a very low, and in fact, I get there. My channel says it doesn't exist.
Russell,
that's what they do. We're not in the search system. That's the whole point. But anyway,
I love you, bro. Hey, he makes some good videos. Check out Russell Brand. He really does. Hey, whatever. Say what you want, but I mean, he touches on topics that make a lot of sense. So check him out.
Okay.
Anyway, should we say goodbye for now, then, guys?
Sure.
On the recording. We'll say goodbye when I've pressed the recording. But for sun and moon and everything, thank you very much, everybody, for watching, listening, and mwah, to Joshua, and mwah, to Wide Awake. Thank you very much.
Thank you.
Awake? Hey, there he is. Thank you very much. Mwah.
Thank you, Karen.